Welcome to the second installment of Design in Quantitative Research Methods. This is on quasi-experiments in design. As you remember from the last video, there are four major areas where inferences are made in research design. And what we are focusing on in these presentations is what's called internal validity, the internal validity of inferences. Again, if you read the chapter by Coe in the textbook about inferences, it was largely focused on the second bullet point, construct validity and validity in measurement. But we're looking here at internal validity, assuming that you have measured your variables appropriately, your inferences about the causal relationship between treatment and outcome. So this would be when you have some kind of intervention or when you are looking at some kind of agent that you consider to cause a difference between two groups or a change from pre to post, whether or not something in your design allows you to support the claim that any difference that you find is caused by the intervention that you have implemented. So usually we deal with threats to internal validity other than the social threats, which were covered previously, through random assignment to groups. It is, however, always possible, as we saw with social validity, that the purported cause of an effect, what you hypothesize is causing a difference between means, is not the actual cause. Something else is the cause. And selection is your major problem when you don't randomize. Or when you randomize and when you think you randomize and you failed to do so, for instance, when whatever your randomizing agent is has failed, and there are reasons why that can happen, or when you have differential attrition. So people drop out of one condition for different reasons or at different rates, then they drop out of another condition. All of these things cause selection problems. A selection problem means that rather than the intervention causing the difference in outcomes, there is something about the characteristics of the people who went into the intervention or the characteristics of the people who did not go into the intervention that causes their differences. And this is extremely true in educational research because we look for volunteers. So for instance, if you have non-randomization and you offer a professional development program, then when you try to compare people who have received professional development from people who have not received professional development, then you are always going to find that the people who received the professional development tended to be the eager beavers who wanted to develop professionally. And therefore their motivation for improvement may be a very considerable reason that they actually did, you hope, improve. It may not actually be what you've offered them. It's just that they are the kind of people who respond to anything that's offered. It's a very common problem in any kind of educational research where we allow people to self-select into groups. So selection is your major culprit. And pretty much anything else is a function of selection. So some people, rather than just writing, for instance, history, will write selection by history. selection by maturation, selection by testing, or by instrumentation. I've just written them in kind of short form. But in each of these cases, the issue is that you haven't randomly assigned, and so it is possible that coming into your intervention or at some point during your intervention, something happened to one group that didn't happen to another group. This could be that you have given a intervention with test-taking tips to one group and the other group has not received anything. And even though you didn't use random assignment, the two groups were quite similar to start with. However, the people who received the test-taking tips had a fire drill while they were taking the test. Now, perhaps because of the fire drill, you're not going to find any differences between the two groups in their achievement on the test. However, if there hadn't been the fire group, maybe there would have been, which you're making the causal claim that there was no difference. And in fact, in a perfect world without that selection by history, without that group-based history effect, there might have been a difference. This is what's called a type 1 statistical error, and you'll cover it in statistics class at some point. Another threat is when some students are maturing at different rates. This occurs in pretty much with younger children, for instance, whenever, again, you have, for instance, parent selection into a program, and then depending on the type of program, it could be that parents are sending the kids with the highest needs into the program, who perhaps have highest needs in terms of they're developing slowly. And so then a comparison will make them look like they don't have a difference just because their developmental trajectory was lower anyway than other students. The opposite could happen. Basically, it's very hard to predict what direction differences will happen. Something that's slightly different is a testing effect, which is when, if you offer a pretest to both groups, and then you offer an intervention that obviously targets questions, issues, constructs on the pretest, then you offer a post-test to both groups, the people in the intervention group will be more primed for that post-test. And so we call that a testing effect, because it is not actually the intervention that changed them, it's their recollection of the pretest. And again, you may think that that's unlikely, but it is certainly happened in experiments of quasi-experiments of a certain type. That could actually, I should have listed that also under threats to internal validity with true experimentation. It can come into true experimentation because a priming effect of testing can happen regardless of whether people have been randomized. This is characteristic of the relationship between the pretest and the intervention, not something about assignment. Okay, so that was a little bit of an aside there. Again, though, it does bring to mind that there are numerous, and I do mean numerous, ways of categorizing and describing and layering, particularly, all kinds of threats to internal validity. And it's hard to be exactly precise with them. So for instance, all the social threats under validity, internal validity, and experimental design can also come in here. They tend to be a main focus with experimental design, but they're just as much of an issue here. It's just you have selection as like the dominant issue here. Testing, as I just said, can come both into quasi-experiments and into true experiments. So there's lots and lots of ways. There are a lot more threats than I'm listing. And it's more important that you understand conceptually that all of these issues can interfere with your ability to draw a conclusion about the cause of an effect. And so you have to take steps in your design to improve your ability to draw that conclusion. So as an example, how might some of these threats affect conclusions when you haven't randomized, when you have a quasi-experiment? So researchers use a pre-test, post-test design to measure the impact of two different interventions. Treatment participants elect to receive either cognitive behavioral alcoholism treatment or AA type therapy and are measured on a variety of outcomes. The outcome here we'll say is just number of drinks per week. So you have the two groups, one of them XA is cognitive behavioral, one of them XB is AA. They are asked to report their number of drinks per week prior to entering the treatment plan, and they are asked to report their number of drinks per week when they leave the treatment plan. Now, we're not even going to talk about social threats here because there are a lot of things like experimenter expectancy, diffusion of treatment. Okay, so they actually end up going to both because they really want it. So, okay, so let's start to think about threats. Wow, so many threats to saying, let's say that cognitive behavioral alcoholism treatment has a much greater reduction in number of drinks per week than AA. Okay, so the difference in differences, reduction in drinks for cognitive, reduction in drinks for AA, much greater for cognitive. Great. So you think, oh, cognitive behavioral therapy works. Well, okay. So first of all, people selected into what they wanted. It could be that those who wanted cognitive behavioral alcoholism treatment were, for reasons unknown to us, much more motivated. Maybe they were people who'd already tried AA and it hadn't worked. Who knows? We don't know. You see that we don't know? We didn't randomly assign. And so we can't be sure that all of these different things that might have affected who went into which group, maybe, one of them was offered in the daytime and the other was offered in the night. And the nighttime people were more likely to quit drinking because they were busy at night now instead of going to bars. I don't know, but because you haven't equalized things, then drawing a conclusion that the cause is the nature of the treatment is different. Another thing is that without randomization, let's go back and look, something could have happened in one group. One group might have had a disruption to its facility. That's kind of one of the closest things that the most typical things that you ever see is that something happens geographically, locally, that a whole lot of people in that group catch the flu from each other, and their outcomes are affected by the flu rather than by the kind of treatment they were receiving. One group, as I said before, it could be possible that one group had tried multiple treatments before they went into whichever one they're going into. And so they were already further on their way than people in the other group. Or it could be that they were more resistant to treatment. The effect of taking one or more pre-tests is unlikely in this case. And the effect of lying on pre-tests or on post-test, we'll talk about later. But regardless, there are a lot of things having to do with the experiences of the people that led them to get into one group versus another, and their predilections, their personality types that could make the two groups different and therefore explain their outcomes other than the difference between treatments. So that was a quasi-experimental design. It's a two-group pre-test, post-test, which is generally a pretty good design. And there are multiple other quasi-experimental designs. I'm going to go through these, I hope. I'll try to go through them a little bit rapidly so the video is short, because many of them are similar to experimental designs, except that they don't use random assignment. So we will consider, first of all, what you can do, what you have the ability to do as a researcher. And the first thing you may or may not have ability to do as a researcher is figure out how people get assigned to groups. So in this video, we're saying you don't have the ability to do random assignments, you're going to be quasi-experiment. So what else can you do? Well, to add to the ability to make causal claims, you can use more measurement. So rather than just measuring people on a single occasion, you can do multiple occasions, multiple pre-tests, multiple post-tests, all kinds of, you can measure people on more than one construct. So there are a lot of things that you can do with measurement. And measurement is just more measurement with a worse design is not as good as a better design, but it's very important when you have a quasi-experiment. You can also have more groups. So you can't randomly assign to groups, and therefore it might be desirable not just to have two groups, but to have more than two. And you can look for patterns in the way treatment is assigned. You can look for patterns in your results. Trochim on the research base for knowledge, or the knowledge base for research methods, talks about pattern matching, which is basically making complex hypotheses about outcomes, hypotheses that are hard to support, so that even if you have not that strong a design, your hypotheses are so unlikely for reasons due to chance that they are more likely to be for reasons of causation, or that will be your claim. So we're not going to look at any one group techniques. I think I accidentally put some one group techniques in with the experimental slides, which was regrettable. One group techniques are not experiments or truly quasi-experiments. They're one group treatments. So we're not going to, they're non-experiments. We're not going to go back and look at them again. But there's some kind of quasi-esque things that you can do if you only have one group, which I will mention. So you may have published norms, you may have census data, you may have like institutional data. And that would, in many cases, be a one sample z-test against a norm or against data from your institution. And that can be pretty compelling evidence. I mean, if you've got like 6 years where the average for students who were taking the LSATs in their senior year of college, the average LSAT score was in the range of, you know, insert number here to insert number there with a mean of such and such and very little variation, then you can compare that to your new distribution of LSAT scores. And if the difference is large, if your effect size is large, that, unless your school, you'd want to document that the college hadn't instituted special programs, you'd want to document that it was not a non-randomly different cohort of students, like look at their incoming SAT scores or something. But if they were similar groups of students and the institution was operating in a similar way, institutional records or published norms can be useful. You can also do an analysis by strength of treatment. Like if you only have one group, but they're participating at different rates, just voluntarily. Some of them come 5 hours a week, like it's a tutoring center. Some of them come 3 hours a week, some 5, some never, some once a month, blah, 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 blah. You can look at the outcomes by, for instance, hours that they attend. This has a lot of flaws in the design, but it is definitely a possibility when it's an appropriate method. When you have multiple, or you can make multiple groups, and that means just collecting multiple groups. It means, for instance, you might have a treatment, published norms, and last year's local sample. And so if you can prove that you're different from like a national norm and last year's sample, and for no other apparent reasons, that could be a compelling argument in the absence of random assignment. You can say, well, okay, so I have I'm trying to think of a good example. I've instituted an intervention that is supposed to target school attendance. I hope I get this right. Let's even go so far as to say class punctuality. And I have this year's class punctuality, and I have last year's class punctuality, and I have a adjacent grade levels class punctuality. So I got 3 groups. This year's class punctuality is the one where I'm doing the intervention. So I'm doing an intervention this year. I have last year. I have 10th grade, whereas I'm doing the intervention in 9th grade. You can point out a lot of flaws to doing them at different years, developmental years. So I measure them on punctuality. I also measure them on math achievement. Or how about this? I measure them on classroom engagement and math achievement and 3 other things. I don't expect any of those things to change due to the punctuality intervention. The punctuality intervention was only about punctuality. So now I've set up this kind of pattern. It's a complex prediction. What I'm saying is, among the tests, I am only hypothesizing a significant difference in one dimension. So if you find it all over the place, then that suggests that it's just chance. If you find it exactly where you claimed you're going to look, kind of like being on a treasure hunt. Okay, so if you are on a treasure hunt and you spend an hour and a half and you look in every single teeny tiny nook and cranny of the location and you find your treasure, it's like no surprise. Well, that was just chance. You had no idea where it was. But if you go straight, your hypothesis is exact, and you go straight to the place, then that suggests that you knew straight where it would be, that you had a very specific hypothesis that it would be on punctuality, and you were affirmed it was nowhere else. But I'm not going to talk about retrospective pretesting. I believe it can come up later with measurement. It's a way of substituting pretesting for asking people to remember. Having more groups is always beneficial. We've already looked at this 2-group pretest, post-truth test, very common design, either with randomization or without randomization. We looked at it with randomization, but selection can cause you all the troubles in the word. So there's just selection, and selection by all its interactions is still going to be an issue. Maybe people got into your treatment group because of a characteristic that made it so that they had an outcome for the X group that was different from the outcome for the no X group due to reasons that are not the intervention, nor are they chance, which would be covered by random assignment. They are something else having to do with who they were and probably how they got into that group. Some of the things you can do with that is you can actually have better records of what people were like before they got into your treatment group. And this is really nice to see if 2 groups are maturing differently, because you have a sense of how stable they are on whatever it is you're measuring before they get into your treatment group. And this becomes something you can statistically model. So those are nice things. You can't adjust for history. Something could happen to people during the treatment that would affect the outcome other than the treatment. But this is a nice design to use multiple observations, get a stable baseline before treatment begins. Some extra designs that can be really cute are when you start to do some more complex pattern matching, as is discussed in Trochum. This is called switching replications with a comparison group, and it can also be really useful in field research as delayed treatment. Now, you could get into look back, listen back on treatment diffusion and compensatory equalization among the social threats, which can be at work here. But basically, one of the things here is, say, and it's not listed on the slide, but say you have this really cool treatment. You really want a comparison group, but you can't get anybody to be randomly assigned to it. And you don't feel 100% comfortable just saying, well, you can't have it, but I still want you to be my comparison group. So what you say is, if you will volunteer for your students to be measured twice during the first 3 months of the school year, when I'm going to implement this intervention, Then when that 3 months are over, I'll turn the intervention over to you and you can have a turn. And some places will be willing for that wait time. Now you're hoping that they're not putting something in the interval. You hope they're actually waiting, but then you can do cool things. Like you can just act like it's a pre-post treatment, no treatment thing, which is the first half of this picture, O1x02 over O102, and compare outcomes or compare change. But then you can also look at stability. What happened to the first treatment group over time? Did it delay? Was the effect maintained or did it drop off? So there's some nice things you can do with this design if it's a possibility. Oh, I guess that's the last thing for the quasi-experimental group. There is a third presentation on some kind of just some extras, single case design, time series, and matching or statistical covariation that I will post shortly. Thanks for your interest.